Buckle up, everybody, because today we're going deep, deep down the rabbit hole into some pretty wild scientific ideas. We're talking about atoms, electricity, and maybe even a whole new way to think about how the universe is put together.
Yeah, it's exciting stuff. And the source material is, it's not your typical research paper. We're actually looking at this translated document. It's in Spanish, called La Revolución del Modelo Electroatómico,
Okay.
which is a compilation of
Whoa.
translated Russian scientific articles.
It's like a deep dive within a deep dive.
Exactly.
And to make things even more interesting, the guy who translated it, Raul Pelaez Mendoza, he's an expert in Atlassian Jira and agile methodologies.
Right.
You wouldn't normally connect that with, complex physics and stuff, but hey.
It's true.
It just goes to show you that fascinating connections can pop up in the most unexpected places.
Absolutely. And the ideas these articles present, the Russian articles, they're really revolutionary. I mean, they're suggesting that the way we understand the atom now, the one we all learned in school, with the electrons orbiting the nucleus, it could be completely wrong.
Okay, so we're talking about a total rethink of how we understand the atom. What's their main problem with the model that we're all, pretty much familiar with?
Well, they argue that the traditional Rutherford-Bohr model, it's just too abstract.
Okay.
And it's full of inconsistencies. They say it's like building a house on a foundation that's full of cracks. It might look okay on the surface, but it's fundamentally unstable.
Gotcha. So what are the consequences of this kind of shaky foundation? Why should we care if our atomic model needs a little tweaking?
They believe that these inconsistencies, they're actually preventing some major scientific breakthroughs, especially when it comes to understanding the electromagnetic field. It's like trying to solve this giant puzzle, and we're missing some of the pieces.
So they think we can find those missing pieces by totally reimagining the atom. What does their alternative model look like?
Well, they have this idea of a fundamental particle they call the electroatom. And it's pretty different from what we're used to. Imagine instead of a nucleus with electrons orbiting around it, you have a sphere, and it's made of pure electrical energy.
Yeah.
And that energy is just distributed evenly throughout the sphere.
Whoa. So no protons, no neutrons, just pure electrical energy packed into a sphere. How does that even work?
Well, that's where things get even more interesting. The document actually spends a lot of time challenging the way we even think about electricity. They take issue with, the very concept of positive and negative charges. Like they think that might be based on a historical misinterpretation.
Wait, are they saying that the plus and minus signs that we all learned about in basic science are wrong? How could that be?
Well, they suggest that Benjamin Franklin, who first assigned those positive and negative conventions, based on his work with static electricity, he might have actually led us down the wrong path. They think the key to a more accurate understanding is focusing on what they call triboelectricity.
Triboelectricity. I got to be honest, that word is not ringing any bells. Can you break that down for me?
Sure. So think about like everyday static electricity, like when you rub a balloon on your hair and it sticks to the wall.
Right.
Or when you get a shock from touching a doorknob. That's triboelectricity in action. And the authors believe it reveals something really fundamental about the nature of electricity itself.
Okay, so instead of thinking about electricity as this flow of electrons and holes, like in traditional electrical theory, they're suggesting that this static electricity, it holds a deeper truth.
Exactly. They believe that if we focus on triboelectricity, it'll lead us to a more accurate model of how electricity actually behaves in all its forms. And this connects directly back to their idea of the electroatom.
Okay, I see the connection now. So they've got this new electroatom model and a totally different way of thinking about electricity. How do they put it all together? Do they have their own version of the periodic table?
They do. It's called the Periodic System of Electroatoms, or PSRUS for short. And instead of being organized by atomic weight like our periodic table, it's arranged by something called volumetric electric density.
Volumetric electric density. Can you translate that into, English for those of us who don't speak fluent physics?
Sure. Imagine you're packing flour into a measuring cup.
Right.
You can pack it loosely or you can pack it in really tight. Volumetric electric density is kind of like that. It's a measure of how tightly packed the electrical energy is inside each electroatom.
Gotcha. So their periodic table is arranged based on how densely the energy is packed inside each electroatom. What else makes this PSRUS unique?
Well, they use a binary counting system to organize all the electroatoms, kind of like the ones and zeros they use in computer language.
A binary system. That's a pretty unusual way to arrange a scientific system, isn't it?
It is. And it gets even more, more interesting. The PSRUS also uses symbols from different religions, like the yin-yang and the crescent moon, and even the Christian cross.
Hold on. Religious symbols in a scientific system, are they suggesting there's a link between ancient wisdom and this new scientific understanding?
It's a fascinating connection, isn't it?
Hmm.
The document definitely seems to hint at the idea that ancient civilizations might have had a much deeper understanding of the universe than we give them credit for.
Okay, so we've got a revolutionary new model of the atom, a periodic table based on a binary system, and maybe even connections to ancient wisdom. This is a lot to take in. Is there anything else we need to, consider before we try to wrap our heads around all of this?
There's one more piece to the puzzle, I think, that's really important for understanding their perspective. They bring up this concept of the Overton window.
The Overton window. Isn't that a political theory about what ideas are considered acceptable in, like, public discourse? What does that have to do with atoms and electricity?
Well, they actually draw a parallel between the Overton window and the control of scientific knowledge. They suggest that throughout history, certain groups have influenced what scientific ideas are considered acceptable, often for their own benefit.
So they're saying that even if this electroatom model is correct, it could get dismissed or ridiculed just because it falls outside of what's considered mainstream science.
That's exactly their point. They make this analogy to the tailor's rule, like how one misplaced button can throw off the whole garment. They argue that even a small error in our fundamental scientific understanding can have major consequences down the line.
Wow, that's a powerful image. So we're looking at a challenge to the standard model of the atom, a new model based on these electroatoms and a binary system, and maybe even a connection to ancient wisdom and this idea that scientific knowledge itself could be controlled or manipulated.
And that's just the tip of the iceberg. We haven't even talked about their analysis of mathematics yet and how that might be distorting our understanding of the universe.
There's more. Okay, I think we need to take a moment to process all of this before we dive into the world of mathematical mysteries.
Sounds good to me. Let's take a breath and just say, reflect on what we've uncovered so far. What's standing out to you the most from all of this?
Honestly, it's mind-blowing to think that, something so basic as the atom, that our understanding of it could be so completely wrong. And this whole connection to ancient wisdom, it's pretty wild to think that maybe it knew things that we've, totally lost track of.
What I find really fascinating is how the authors weave together all these seemingly separate ideas, like science history and philosophy. They use it all to create this totally different picture of the universe.
Yeah.
And that's where their analysis of mathematics comes in.
They really go deep into the multiplication table. And to be honest, I'm having a hard time seeing how multiplication fits into all of this. We all learned those times tables back in elementary school. What could be so groundbreaking about that?
Well, that's precisely the point they're making. They're arguing that what we take for granted as simple multiplication, it might actually be a distortion of a much more fundamental way of understanding numbers. You see, they propose something called RUS counting, which is this binary system they believe was used by ancient civilizations.
Okay, so instead of our regular base 10 system,
Right.
where we count in tens, hundreds, thousands, and so on, they're talking about a system based on powers of 2, like ones and zeros.
Precisely. And they suggest that this RUS counting, this
Yeah.
binary system, it was the original way that people understood quantities. They even go so far as to say that our current decimal system might be a deliberate attempt to obscure things, to hide this ancient knowledge.
Wait a minute. Are they implying that someone intentionally messed with our number system to keep us in the dark? That sounds a little bit like a conspiracy theory.
Well, they don't use the word conspiracy specifically,
Yeah.
but they definitely argue that throughout history there have been certain groups who benefit from controlling knowledge and shaping the way people perceive the world.
Okay, let's just step back from that for a second and focus on the math itself. How does this RUS counting connect to their whole argument about electroatoms and a new model of the universe?
But they use RUS counting to explain how their periodic system of electroatoms is structured. Remember, it's based on a binary system. They believe that structure reflects a deeper truth about the nature of matter and energy.
So the way these electroatoms are arranged, their positions in this new periodic table, it's all based on these ancient binary principles. That's pretty wild.
It is. And they see this connection as evidence that ancient civilizations might have had a far more advanced understanding of the universe than we give them credit for.
Okay, so let's recap for a second. They're challenging how we understand atoms, electricity, and now even basic math. It's like they're trying to rebuild our entire scientific framework from the ground up. But do they offer any concrete evidence to back up these really radical claims? Or is it all just theoretical?
They do point to certain anomalies in our current scientific understanding, things that don't quite fit with the established models. One example they highlight is the orbit of Neptune.
What's so strange about Neptune's orbit?
It deviates from the pattern we see with the other planets. If our understanding of gravity and planetary motion was totally accurate, Neptune's orbit should fit perfectly within the existing model. But the fact that it doesn't suggests that maybe we're missing something fundamental.
So they're saying that this anomaly, this weirdness in Neptune's orbit, it points to a flaw in our whole understanding of how things move in space.
Exactly. And they believe that their electroatom model might hold the key to explaining these inconsistencies and filling in the gaps in our current knowledge.
It's hard to argue with the fact that there are still mysteries out there in the universe that we haven't completely figured out. But is that enough to justify throwing out centuries of scientific knowledge?
That's the big question, isn't it? They make a very compelling argument. But it's important to keep in mind that we're dealing with complex scientific concepts. It takes time to really evaluate claims like these, to weigh the evidence carefully, and consider different perspectives.
Right. We can't just toss out centuries of scientific progress based on one single document.
Definitely not. But I do think it's incredibly valuable to engage with these unconventional ideas, to explore different ways of thinking about the universe and our place within it.
It really makes you wonder what other truths we might be taking for granted without even realizing it.
And that's what makes science so exciting, Reddy. It's a constant process of questioning and exploring and refining our understanding. We should never be afraid to challenge the status quo and dig deeper into the mysteries that are all around us.
So where does all of this leave us? We've explored this radical new perspective on the atom, we've questioned the very foundations of electricity and mathematics, and we've even dipped our toes into this idea of ancient wisdom. What are we supposed to make of all these wild claims?
I think the most important takeaway from all of this is the importance of critical thinking.
Critical thinking.
Yes, it means approaching new information, especially when it challenges established ideas, with a healthy dose of skepticism.
So we shouldn't just accept these claims at face value.
Exactly. We need to carefully consider the evidence they're presenting. Think about where the information is coming from, and look for any potential biases that might be at play.
But at the same time, we shouldn't just dismiss these ideas out of hand just because they sound strange or unconventional. It's about finding that balance right.
You got it. It's this delicate balance between healthy skepticism and open-mindedness. We need to be discerning in how we evaluate information, but also be willing to entertain new perspectives.
It's like we need to develop our own internal Overton window, one that lets us explore new ideas while still maintaining a critical lens.
I love that analogy.
Okay, so critical thinking is key. But why should the average person who isn't a scientist or a mathematician care about this whole debate over atoms and electricity? How does any of this affect their daily life?
I think it comes down to curiosity and a desire to truly understand the universe we live in. If we're genuinely curious, we have to be open to exploring different viewpoints, even the ones that challenge what we think we know.
It's about expanding our sense of what's possible.
Exactly. And who knows, maybe by questioning these fundamental ideas, we can unlock new discoveries and innovations that we never even imagined before.
It's like they say the only constant is change. Even in science, we should always be ready to adapt and evolve our understanding.
Absolutely. That's what makes this whole journey of discovery so exciting. There's always something new to learn, always another layer to peel back and explore.
It's pretty amazing to think that we can all be a part of this scientific journey, even if we don't have a lab or some fancy equation named after us.
I agree. It all starts with that curiosity, that willingness to question what we think we know and just be open to new ideas.
Well, this deep dive has definitely made me curious, that's for sure. We've covered a lot of ground, a whole new way to think about the atom, a periodic table based on ones and zeros, questions about electricity, and even like the foundations of math. It's been quite a ride.
It really has. And we might not have all the answers yet, but we definitely have some fascinating new questions to think about.
Like, what if this electroatom model is actually right, or even partially right? What would that mean for how we understand the universe and our place in it?
That's a huge question. What if energy and matter are even more connected than we realize? What if the key to new technologies or even solving some of the biggest problems we face is to rethink these fundamental building blocks of reality?
I know it's enough to make your head spin. We've explored some pretty complex stuff today, but I have a feeling this is just the beginning of the conversation.
I think so too. This deep dive has opened up a whole new way of looking at things, and I hope our listeners will want to explore further.
Speaking of our listeners, we should mention that the document we've been talking about, La Revolución del Modelo Electroatómico V2.pdf, it's available online. It's a tough read, but it's definitely worth checking out if you're ready to dive deeper into these radical ideas.
For sure. And don't be afraid to ask questions. Explore. And keep an open mind. Who knows what amazing discoveries are waiting for us if we're brave enough to challenge the limits of what we think we know.
It's like we've been given a whole new set of lenses to look at the world through, and what we see through those lenses might surprise us, it might challenge us, but it could also lead us to a much deeper understanding of ourselves and the universe we live in.
Well said. The journey of discovery never really ends, and the universe is full of wonders just waiting to be discovered.
Thanks for joining us on this incredibly deep dive, everyone. Until next time, keep those minds curious and those questions coming.